Hi, everyone, and welcome to the webinar. My name is Sven, and I'm actually from Germany. I came to the United States about 2.5 years ago, and I studied in Virginia at George Mason University. I had my graduate studies there in information systems. Graduated last year in March to then join Syrian Software and work on iFormBuilder. I'm actually right now working in the infrastructure team. So that means we're taking care of all the servers, all the backend that you usually don't see. So our team is about 3 people. So we're 3 people in the infrastructure team, and we're making sure everything is running. And with that, I want to start off that webinar here. I'm very glad that you all joined, and I want to talk to you about how your data is basically processed once it goes out from your device, how we store it. Of course, we also have to back it up in case there is any problems, and also how we recover data in the case there are problems. So first of all, I want to give you an overview of our infrastructure. So as I said, I'm part of a 3-person team that takes care of the infrastructure. And surprisingly, we have 150 servers, actually a little bit above that number. And we, as a 3-person team, we take care of those 150 servers in 3 different data centers, which are spread across the US, also in Europe, specifically the UK, and Australia. So if you think about it, the traditional approach really is to having a data center. Back in the days, maybe 10, 20 years ago, everyone would have a data center in their company. So you would have to buy machines and basically computers. You would have to have technicians who take care of those computers, make sure that they, when the hardware is broken, that it gets replaced. That was back in the days. But we at iFormBuilder, we're working at the current speed, so we use state-of-the-art technology, which is, of course, the cloud infrastructure, the buzzword, which basically means nothing else than we hire a company to take care of all the hardware issues that come up. They provide us with the means to develop our software and keep the system running. So our cloud provider is Rackspace, and of course, as you see, with 150 servers and 3 people, it gets very confusing quick, and you need to have some sort of stabilizing element in it, and you need to make sure what's going on your servers, and that's why we employ 24/7 monitoring. We basically have a software there that is installed on all those servers and basically tells us what the status of the services on the servers is. For instance, applications that are running or maybe not. Maybe I need to explain the concept of a server a little bit more. I'm assuming everyone knows what a server is, but maybe not. So just to tell you about that, a server is basically like a computer, but they are more basically ramped up. And what they are basically doing is serving requests, hence the name servers. Servers can have many purposes.
So before you go any further, Sven, there's two things that I want to mention. One thing is that with these data centers, I usually think of like the Mission Impossible, where people have to go in and then try to steal the data, and it's in a dark room and it has to be a certain temperature. Is that what a data center is?
Well, it's not quite that dark of a place, but let me put it this way. So with a cloud provider, it certainly is a very a secure thing. This company, Rackspace, they have these server farms, and basically they have many machines, and what they basically do is they take good care of it, and there are dedicated rooms where that are secured physically, and then there are, like I mentioned, technicians and people that are taking care of it. So it's not quite that dark.
All right, thank you. And then the other thing is, you mentioned that we have 3 data centers, the US, the UK, and the AU. Is there a reason that we chose those 3 locations? Is there a reason that we don't have more locations? Why are those 3 the ones that we use?
So those 3 are actually, we started out with the United States. We have 3 data centers here in the United States. So 3 locations. This is, of course, as we started out, and then we started to get, acquire customers from all over the world. And, when you, for instance, have customers from Australia or the United Kingdom coming into US servers, maybe the response time isn't that great. I mean, we're still able to serve requests, so we're on the good side with that. But just to increase performance, we chose to have a data center near the location where our customers actually are, so it works better for them.
Great, thank you.
All right, then I will continue. You've probably seen the screen a lot on your iPhone, maybe also on your Android device. So we are going to talk about this process. What actually happens for you is probably more like, okay, I'm sending it to iFormBuilder.com. But what does it actually mean? What happens in the backend? First of all, I want to make an analogy because I know what I'm going to talk about is pretty heavy material. So I want to take a real life example, and specifically in a time before iFormBuilder, where we still, worked with paper, filled out paper forms, collected them, and archived them. So the usual process is, you have someone fill out a form. You collect all these forms and then give it to someone that processes them. They maybe bring in into a certain shape or into a certain format. Maybe put it in an Excel sheet and print it out again to have even more paper. And then finally, of course, you want to store the data somewhere, so you have this huge archive, with many folders. So just bear that example in mind. I'm going to refer to that in the next couple of slides. Because with iFormBuilder, things changed a lot, and we're now basically taking out all the tedious manual steps and are replacing it with an digital approach. So instead of going out and having someone fill out a paper form, you know that already. You go out with your mobile device, you collect data. So what happens next? You sync, and you have your device connected to iFormBuilder.com, or if you have a dedicated database, it would be your URL .iFormBuilder.com, and you send it out there. So what happens next? First of all, the data goes to an application server. That would be similar to the person on the desk that we saw in that earlier picture. So that application server takes the data, makes sure that the communication is correct so that it received all the data from your mobile device, nothing gets lost. And then also, brings it in a shape, maybe in a certain type of format. So like the other person did before in that slide, where she put it in an Excel sheet and then printed it out. The application server does that as well, but it doesn't print out the data, right? It puts it actually into a database server once it's done with its process. And the database server is pretty much the same as the archive that we saw in the previous picture, where we had those many folders. It's an organized data store, and your data is kept safe in there. And as you can see around here, I didn't even mention that is basically the cloud, and that demonstrates our provider, where we have all our data stored. So it's not on site, it's with the cloud provider. So now you probably say, okay, this is a pretty easy job. You know that architecture is so simple, I could probably do it myself. But you know, of course, most things in life aren't easy. So that's why I present to you, the more in-depth approach. And this is a better approximation of what our infrastructure really looks like.
That's
So
crazy
you
that
can
there's
still
so
see,
much there. There's
yeah,
so
yeah.
much.
It's just, it's just incredible. It's also for me. So if you're overwhelmed by that picture, I can definitely understand it. I can relate to it. Um, when I came to the company about 9 months ago, I learned a lot. But at the very beginning, when I was shown all of this, it was just okay. Where am I going to start? What am I going to do now? It's just sometimes it's overwhelming. But I had, to, like I said, during these 9 months, I learned a lot and I got into it pretty quickly. And I'm trying to get you to a point where you can at least understand part of it. So I know it's difficult, but you know,
Is
I'm
there a
trying.
reason that there's so much to it?
That is actually a very good question. So if you think about the previous picture, if we go back, we see, okay, we have a mobile device that sends data up into the cloud. So we have one application server there, one database server. The natural question comes up, or maybe you ask yourself, okay, what happens? What happens if that application server goes down? Maybe there's a power outage or whatever. There could be an event that an application server goes down. Maybe the database server goes down. Maybe it has a hard drive failure. Um, so we cannot rely on one machine. Rackspace takes care of, of those servers as good as they can, but if something happens, if a hard drive dies in a machine, there has to be some sort of failover. They can only replace it. They cannot instantly fix it by pressing a button. So we also have to take security measures, and that's where this whole architecture comes into play. So
So, so Sven, last week, I know that you and the team had to take turns staying up all night, making sure things were going smoothly. And I have no idea what you guys were doing, but does it have something to do with this architecture?
it does have to do something with that architecture. Actually, that's a good point. So last week, actually 2 weeks ago, we got an email from Rackspace, and they were telling us, okay, we've got a critical issue on pretty much all of our servers that needs to be addressed and patched. So there was something deep in those machines that has to do with virtualization. I'm not going to go any further into that, but just to give you an idea.
So
So
if you and the team didn't stay up late trying to monitor this, what would have happened?
so yeah, what I was going to say is Rackspace basically said in that email, we need to reboot all our machines. So we need to take them out one by one and install that patch and bring them up again. So that is not you know, the reboot is not in our control. When a machine goes down, it goes down. We can take preventive measures, but ultimately Rackspace takes them down. So what we did is we had a time window. They gave us a time window from 11 p.m. I think it was on a Wednesday night or Thursday night, 11 p.m. to 5 a.m. And okay, they said we're going to take out those machines and install that fix for you, and then we're going to bring them back up. And I mean, yeah, that's the ideal scenario. And they say, okay, they're going to be up again. But really, the thing is, you can never be sure. You can never be sure that everything comes back up again. That is really the problem. So we had to be up on our side, had to drink a lot of coffee, and actually make sure that those machines came back up again, because there are certain applications on them. Some of them did not start. So I was actually, a little bit sweating a little bit to get them fixed. But ultimately, it worked out. We only had a little downtime. So yeah,
What would
but
have happened if
to
it didn't
to
get
relate,
fixed?
if it didn't get fixed, well, then there would have been probably a little bit of downtime. Not only a little bit, a lot more, because those app servers were not coming back up again, or at least an application on there was not coming back up again. And as you can see, the picture is quite complex. So there could be many problems occurring in that whole infrastructure. Is a very complex thing, and you have to start troubleshooting first. Okay, which one of those machines is it going to be? And yeah, we ended up finding out it was the app server, and the app server, as we said in a previous picture, is responsible for serving you the website and also talking to your iDevice or Android. So
So if that didn't come up, then people wouldn't have been able to log into iForm and use that?
yeah, that is correct. There would have been, nothing coming back from our side if we hadn't been up all night.
Well, I'm glad that didn't happen, so thank you.
Yeah. So that was quite a thing. Um, so to relate that back, actually, we need that complex architecture to make sure that those um, problems that happen, that they're not taking our entire system down. We have a couple of backup servers, as opposed to in this picture where there's only one server that we can basically activate in that case, and let them run, so they can take over the responsibilities of the failed servers. So let me just draw the parallels here real quick from the previous picture. So I told you there's an application server that is still in there in that picture. They serve you with the website and also communicate with your device. We have a database server here, and we can also find it over here. So we've taken care of this layer. You know what it is. If you need further explanation, you can also let me know. I'm glad to talk about this and go a little bit more in depth. But so as you can see, we have now there are app 1, app 2, and app n. So depending on our environment, we have a couple of those architectures. So it's not only one. As you've seen, we have 150 servers. Of course, they're not going to be all communicating in well, they're not going to all be communicating as in this picture. So there's many of them. So they're not all of them in this picture, but there's many of those similar structures. And what we actually see here right now is we have those black boxes. Those are the ones I haven't talked about yet. So what do they actually do? They say LB1, LB2. What does that mean? So LB stands for load balancer. It is good to have backup computers and everything running, but if you still have to switch manually when a machine goes down, then there's really not of any help. Really not of any help. So what those machines do is say, okay, we take that request and we see which machine is up, which app server is up. These app servers sometimes go down because they have a high load. They have a high number of requests that they need to process. So these load balancers say basically, app 1, are you up? App 2, are you up? How many requests do you have? Can I put more on your table? To put it in that analogy again. So can I put more data on your table? and then app one maybe says yes or no. Similarly, app two and the other app servers that are here, that would be the first scenario. Also, the other scenario would be, as we talked about, failover. Those load balancers also help and talk to the app servers and try to figure out if they are even there. So maybe it could be the server is down, and that's what I was talking about. If the server is down and we would have to manually switch it, there would be no use of it. That's why LB1 keeps in check. Okay, are those servers up? If this one is down, I don't need to send any data there. That's why I go over there. So that is the use of those load balancers. Similar here on the database level. Also, because of availability and the previous concepts that I just talked about, and they're giving the data down there. So basically, the main reason why we have so many objects in this diagram here is just to ensure that we have, failover capability. If one machine goes down, you will still see your screen. You still will be able to upload data. So for those of you who are familiar with the Thunderplug, I just want to talk about it really briefly. For those of you who are not, the Thunderplug is actually a device that you can use for offline data gathering. So that means basically in areas where you don't necessarily have a Wi-Fi connection or where you don't have a data connection either, you still want to sync your data to a device and be in an environment where you can still manage all of your iFormBuilder functions. So these Thunderplugs are actually emulating this whole server environment I was talking about earlier. So not this one, we don't need as much failover capability, but rather this one. Since when you're out, you connect at max maybe 10 devices, and you upload data. And those Thunderplugs are little devices. So what they actually are, they are exactly this environment. They are an application server and a database server, all in one neat little device. So now, for those of you interested in actually what software we are running, so that goes a little bit more in depth, and I won't talk about it too long because I know for most people it will be tedious. So I'm just going to tell you that we use Percona ExtraDB for database clustering. So we have many database servers, and they also need to be in sync. So that's why we employ clustering. We have the MySQL master-slave replication in place for database servers that need to be backed up on a regular basis. So we actually do live backups to another data center. In case one data center has a problem, we send the data to another data center on a constant basis. So we can put in failover mechanisms and point to that other data center. We also use HA proxy, that tool I was talking about earlier that is employed in the load balancers. So it basically routes all requests. We use RabbitMQ. That is a tool that is queuing requests from the application server. So sometimes we have long-running requests, and in a regular environment, they would time out. That's why we have to employ a queue. We use Puppet for maintaining our servers. So actually, that would be probably interesting to most of you to know. I always bring up 150 servers, 3 people. How do we do it? With Puppet. It's basically a software that we install on each of those machines, and then we have another server or computer where we basically give a configuration and tell, okay, Puppet, you install on all those machines that we've just said or told you to install on these software packages, or you configure it that way, or you put firewall rules in. So that makes it very easy for us to maintain all those servers. And now, really, one of our key tools is Nagios, and this comes back full circle to the 24/7 monitoring I was talking about. So apart from the incident we had last week that Barrett asked about, where Rackspace actually told us that they were going to take servers down, we also sometimes have, throughout the days, we have just regular incidents coming in. There's a a hard drive filling up that needs to be sometimes needs to be cleaned or needs to be enhanced in storage. And this tool actually helps us. Nagios, it sends out emails and tells us which servers are affected. And sometimes throughout the day, I get, as little as 50 emails, which is good by my standards. And there are sometimes we have days where there's a lot of things going on, and it's 200 emails and up are coming in. So these come in 24/7. So that means also for us as a team, 3-people team, sometimes before going to bed, or even while sleeping, we get those emails, and if they're critical, we get up, we fix them, because ultimately we want that everything is running nicely. And yeah, that's basically a big help to us, this tool. So now you're thinking maybe, okay, that's cool, everything you told me about, yeah, sounds about right. Maybe I totally get this is a lot of information, and it's very, very complex, and maybe it's not for everyone. I certainly had my problems when I started out grasping all of this, and let alone I'm telling you about this in about 30 minutes. So what are the real benefits? Why am I telling you about all of this? So my first point is your data is in good hands. Your data is in good hands. So what I mean by that is you can trust us with your data. You've seen the complex architecture. We put a lot of thought into that to actually make sure that your data gets to us, nothing gets lost, and we store it, and do all our best to keep it where it is. So I have a couple of points here that I briefly want to go over, and the first point is high availability. So that's what I was talking about earlier in those diagrams. High availability, basically, I mean by that that if there's any server error, if some of the machines even fail, we still have failover capability. So we have a lot of backup servers that can actually take the responsibility of that machine that failed and keep our servers available, iFormBuilder.com. We also have redundant data storage.
What is redundant data storage?
Redundant data storage basically means you make copies of data. Sometimes redundant data storage can be something you want. Sometimes it can be something that you don't want. Redundant data storage could be if you send out if you have to work with a colleague and you're working on an Excel spreadsheet, and you're working on a version of it and send it to your colleague through email, and they work on it, and there's you create duplicates, and in that case it would be bad. But redundant data storage is also a very good thing. And specifically in our case, redundant data storage is essential, because what we basically do is, with those database servers in that picture I showed earlier, those 3 database servers, they are always synchronized. So what do I mean? If the load balancer pushes data to one database, this database makes sure that all the other database servers that are in that cluster get the same data state. So what benefit does it have? Well, why do all this? So for the easy fact, this one goes down for whatever reason, if that fails, I can say, okay, I have 2 exact copies still running. So I can just fall back on those 2 and take care of this one. There will be no outage. And that is a very substantial thing. The other thing is also that I want to, tell you about. We also secure our servers. So we don't only take care of things on the inside the data center, but we also try to prevent someone coming in. You see those firewalls, maybe that makes sense right now. We also put firewalls in place so that the servers are actually protected. So, when we hear a lot about hackers in the news, and those firewalls are actually helping to keep hackers out. So we have a lot of other security measures in place. I don't want to go too deep on that. That could be probably an entire webinar. So I'll just leave it at that for now. But if you have any questions, feel free to ask. So now that we've talked about the running systems, I also want to talk about the backing up. So we all know it from our laptops, our computers. We do backups just to make sure, once our hard drive fails, that there's still data there that we can fall back on. And that's exactly what we do here, specifically for our databases. For your data, we're backing up your data, and we do that by nightly backups, by the way of nightly backups. So that means we run a process every night that is basically taking all the data from the databases and putting it in one file. So the purpose of that would be, for instance, we have several customer requests sometimes coming in, and we all have our days, and imagine you had a day where you just created a new form, you collected data on it, but you figured out you don't need that form, or that form doesn't serve a purpose. So the thing is, you delete that form, and later come back to realize you accidentally deleted an entirely different form that maybe has a similar name, but there were 800 records in it. So how do you get that data back? That's what these backups are for. So we are actually taking care of that case by making nightly backups. So at midnight, every night, the process runs, and we make sure your data is still there. And that those backups are kept for 1 year. So if you need to recover, we've got nightly backups. An added bonus is for customers in the US that have dedicated databases. We also have the capability of backing up those databases every 4 hours. And we usually maintain those backups for 4 days. So those are even more precise snapshots. So it's not night by night, but really every 4 hours. So in case something happens, we can be a little more precise on recovery. Also, what I want to make sure is that you know that we, of course, encrypt those backups, because if they're in place somewhere, sometimes it happens that a system is compromised, but this is not a problem because we encrypt those backups. We have them actually in a place. You can think of it as a zip file where you put a password on it. It's a little bit more complex than that, but it doesn't help anyone if they don't have an encryption key, and we keep that encryption key and make sure those backups are safe. Also, another thing is, since I put so much emphasis on failover security, of course, backups also have to be stored in multiple locations. It doesn't help if I put the backups on one server and that server dies. So that's why we put them in multiple locations, which also is basically a good example of data redundancy, very positive data redundancy. So I was just talking about the case you create a form and you accidentally delete another one. So I just wanted to talk to you briefly about the process of how we also bring that data back. So as I've said, we restore data on request. Our support team does that, and I have some part in that, mainly the backend part where I go directly into the database. And our support team, in the first place, they have a tool. We created a tool which has the abbreviation CSIM, and Barrett, I think, has a good idea understanding how that came about, because it happened a little bit before my time, before I came to the company.
So when I first started here at Xerion, there's actually an individual who sat across from me, and his main project was making this customer simulation. The reason for it and how I find it very helpful is there have been times where I'm on a call or someone says, hey, this form isn't quite working. Can you go check out what's wrong with that form? So I'm able to go into the CSIM and upload a copy of their database to be able to view what they have and view the errors that they have in their form. Previously, before CSIM, the way that had to be done is the user had to give me login credentials to go in and view the form. But then also the fact of the matter is that they could have changed something in the interim, so I wouldn't exactly know what I was looking for. So I was able to go in, or now I'm able to go in and see what the form looked like maybe 2 days ago versus what it looks like today, and how there's been a change and maybe why it's not working. So that's really, when it first came about, that's what I know that the main purpose was, or one of the main purposes was to be able to go into a customer's account and to see what was going on and to see maybe where some of the errors were coming about.
Okay, so actually I just wanted to pull up this interface for you so you get a general idea of what our support team does, what also Barrett just talked about. And this is basically that application that they use. It's a simple web front end, really, and it has a couple of slots. I will show that concept a little bit later. These slots, we can select a data date, so we can, of course, we utilize those backups that I was just talking about to actually import data states from previous dates. So I can go back to March 3rd, and I could pull data from pretty much any customer. Of course, this is a demo interface, so you won't see too much of that, but I'm just trying to give you a better understanding here. So if you happen to have a big dedicated database and one specific profile has a problem, this is really helpful, this tool, because of course, putting data back into place always takes a lot of time. And you can sort that basically by a profile ID and say, okay, I just only want to restore this profile ID. I don't need anything else from that database. So now this is support specific. So this is basically a sample right here. Usually there would be all our customers listed and their URLs. And you could basically select a company from there, or a database. And there's just a simple password slot, initials, and basically inform me when the process is done via email. You can type in your email in here. And this is basically what it looks like then. So it's doing all the magic once I press go. And once it's done, it tells me, okay, I'm done. And you see basically, okay, what have I, or what is imported in here? So there's a couple of slots that I've filled already, and one customer has my name. Looks like coincidence. Not really, I set it up. So also we can see when it was loaded and what date the data is from. And you may think, okay, this is all great, but how does that help me? I don't have backend data experience. I don't know how to administrate a database. And that's why we have this. So it's basically a full-blown iFormBuilder application, if you want to. It's similar to a dedicated database, and you can basically now log in and see your data state, or we see that data state from back in time. So it's basically like a little bit like a time machine.
Yeah, that's what I was just going to say. So for those individuals who are on the call, I mean, I'd love to hear from you if you would see this as being helpful. But also, I can only see this as being something that could enhance everyone's iFormBuilder account, just because you can go back in time and you can see what you had, and every time something was lost, you'd have a way to find it instead of relying on us to do that. And the fact that potentially you have a form that you're currently using and you have a problem with it, you're able to go mess around with it without it affecting that form in a copied environment. So I think that's pretty neat. Like I said, if anyone else has some comments on if they're interested or how to use this, I'd be happy to answer those.
So I think that was actually a very good point by Berit. It's not only going back in time. If I wanted to, I can pull today's data, and you maybe have something coming up that you want to try out beforehand. What effect does it have? And you just pull the data live from your server, and you can mess around and toy around however you like to. There will be no influence on your production data, and I think that's actually a very good thing. So let's proceed with that presentation. I just want to, tell you something that we still have to do, or that we want to do in the next weeks, months, and even years to come. It really never ends. And that's also, it's a good thing. It's a good thing because always improving is definitely what we want to do. And I just have 3 points here real quick that I want to go over. So failover security, or failover capability is really the key word between me and my colleagues, especially in the infrastructure team, because we want to make 100% sure that there's the least outage. So what we want to do ultimately is spread our architecture across data centers. So just to visualize that, as of now, we have this environment usually, or all of those environments in one data center. So there's a backup option, but that is not a full-blown backup option. It's just a couple of servers. And what we ultimately want to do is distribute those servers that are right here, actually all of them, across data centers. So we won't be vulnerable anymore. If a whole data center goes down, we won't be affected by that. So that's what we're striving for to do. It's kind of a big project, but we're working on that right now. Also, what we want to do is improve our server monitoring capabilities. It's always good. You can never have enough, insight on what is going on. Nagios is good right now, and it serves the purpose. But there's a new tool coming up, and I actually have a typo in there. It's called Sensu. So there's an S missing that we're investigating on. Does it have? Can we replace the capabilities of Nagios and actually make our monitoring more powerful? So that is in the pipeline. And also, of course, an ongoing thing is strengthening our server security. As you know, it is the same with corporate security and also personal security. Of course, corporate security, we have to be up to speed, and private security is up to everyone. You know, everyone can make up their mind about it. But you know, everyone who wants to keep their data safe, you usually install firewalls and antivirus software, and you want to be on the latest definitions of those antivirus software. So there's always something coming up. You can never be on top of it, but you can aim for it to be, you know, at least in the upper 80%. So that's what we're trying to do. We try to stay, we try to keep up with the speed, and we are basically doing monthly scans of our servers. So those are vulnerability scans where we go to our servers and say, okay, you know, what is the status on that one right now? There's a new exploit that can be taken advantage of, and are we protected against that? So we are doing monthly scans, and not only scans, we really, you know, get going to fix that issue once we see it. So other than that, many great features still to come, and at least on the back end, maybe you don't always see about it, but trust me, there's a lot of stuff going on. And with that, I want to hand it over to Berit. Thank you for your attention, and she's going to talk about a few more things, and then we also have a Q&A. I guess you probably have some questions.
Well, thank you, Sven. The first thing I wanted to mention is we are hiring. So if you know anyone who would like to be a part of the Xerion software team, just let us know or let them know. I'm going to put the link that I have included here in the GoToWebinar in just a minute. But also coming up, we have our Power User Summit. And this is an awesome event that we have. This is our second year doing it, but it's been a success, and it's a way for power users or iFormBuilder users to come in and learn from other iFormBuilder teammates or iFormBuilder people and hear ideas, learn integration strategies. But we also have pre-event training. So the day before the event, you're able to come in and either join a Form Building 101 course or a course on integration. If you have any questions on that, just let me know. So that's it for Sven and I want to first thank Sven for joining us and doing this. This has been really helpful for me to see, as well as I'm sure our users. Thank you for attending, and we'll see you next time.